Welcome to 90 Notes. Well, in this worksheet, we're going to use trig for the first time. And it's, this is the way you're going to see it very often. You've got a side that you want to know, you've got a side that you do know in your right triangle, and you've got one of the acute angles. Really means you got them both, but we're going to work with this angle and these two sides to employ trig. So you've had a bit of an introduction about what trig is. So let's just get to a sample problem. In the beginning, I'm going to want you to do this every single time. Relative to the angle we're using, the 41, I want you to identify the opposite side, the adjacent side, and the hypotenuse. Remember, hypotenuse is easy. It's right across from the right angle. Adjacent means it's the one touching. It's the leg that's touching the angle, 41 in this case, and opposite. Remember, the alligator opens his mouth. Over there, this is the one on the opposite side, the only side that does not touch the 41-degree angle. And we have a quick look here. We want the opposite. We know the hypotenuse. Opposite hypotenuse, we're going to use our SOHCAHTOA that we practiced. The O for opposite, H for hypotenuse. That puts the SO in SOHCAHTOA. That's what tells us that we use the sine function. And we're going to say the sine is, of course, the opposite over the hypotenuse. Well, and we're just going to do a little bit of a substitution right there. There you go. So in this example, the sine of 41 degrees is equal to S, my unknown, divided by 73.7. Now, before we bust out the old trig, we are going to let's take care of the algebra. Let's solve for S. Well, that's pretty simple. In this example, we're going to multiply both sides of the equation by 73.7, divide that out nicely, and I'll rearrange it. I'll write it left to right using the symmetric property. And it looks like my unknown side S is equal to 73.7 times that trigonometric function sine of 41 degrees. Now, it's time to talk about this ratio. We know it's on our calculators, but we're going to go old school right here. We're going to go back in the days of the trig table. Yeah, there's a full table like this. It's inside your textbook. It's in everybody's textbook. We've got the degrees, and we've got a column for sine, cosine, and tangent. Yeah, I know you can't read that, so I'm going to zoom in on, just on what we need, on the excerpt right there. For 41 degrees, we've got the sine, the cosine, and the tangent. So left column, degrees, and again, we've got the three there, sine, cosine, tangent. We are going to be using the sine. The sine of 41 degrees, we'll just use that decimal. 0.6561, and go ahead. Just, getting lost here. Yeah, let's just take it right from the table, and all you've got to do now is take out your calculator. You can even use that, wrong. Let's clear that out. We use this cheap little four-banger that you got for free. So we'll take 73.7, and we're going to multiply it times 0.6561, and there's our answer. Rounding to the nearest tenth would be, it'd probably be wise, and it looks to me like we're going to have 48.4. So get that out of the way, and where's our answer there? 48.4. Like it. So that's an application of trig. Let's do some more. Okay, let's do this again. I've got a right triangle here. I'm trying to find the side F. I know this side right here. I know my acute angle. And, we're still new at this, so let's write all these down. Let's classify these three sides. Where is that hypotenuse? Be careful, it's down here. Opposite the right angle, of course. This is my known angle. Relative to that angle, I'm going to call the known side the opposite, and I'm going to call the F what I want, the adjacent. Remember, this is how we set it up in the first place. We go back to our SOHCAHTOA. and we say, I know the opposite, I want the adjacent. Those are the two I care about. OA, opposite adjacent, opposite adjacent. That puts the TOA in SOHCAHTOA. Well, no, we're going to do that. That means we're going to use the tangent function. We're going to write tan on our calculator. The tangent of 19 degrees is equal to, of course, the opposite over the adjacent. So let's write that down. Tangent of 19 is 53.9 over f. Now, hold on to your horses here. This is where most of my students make their mistakes. It's, well, what do we do here? This is algebra. Algebra 1, actually pre-algebra. Let me remind you of something. Would you agree that 100 divided by 4 is 25? I would. And if I rearrange these numbers, well, I could write it this way. 100 over 25 is also 4. Well, look what we did. We didn't change any of the numbers. We simply swapped these two. We swapped the 4 and the 25. And it's legitimate. Now, you could say it's a two-step process. We're multiplying both sides of the equation by 4 and we're dividing both sides by 25. Or you could just say you're swapping the means and the means extremes product property. But no matter how you look at it, this is going to come up a lot in these trig problems. You can swap the f with a tangent of 19 right there. And it's going to look like this. Wow. That makes it easy. So I suppose now, well, let's go to our, in this case, let's dig out that trig table. It's in your textbooks, I think page 925. Or again, you can use your calculator. We'll go old school on this one. And this is an excerpt. I'm going to pull up a trig table and I'm going to find these 319 degrees. I'm going to find these three values. And we look under the third or the last column, and it's going to be the tangent, 0.3443 to the nearest 10 thousandths. So, well, let's just plug that in. And all you've got to do, we'll bust out our simple cheap calculator there, and we'll say 53.9. 53.9 divided by. Now I'm dividing by a number that's roughly a third. That's the same as multiplying by 3, so I expect that my number is going to triple. And there it is, 156.5 to the nearest tenth. So another one done. Awesome. What do you say we give another a try? Okay, I think we're getting the hang of this now. Again, we've got these. We've got a known side, an unknown, and a known angle. So let's go through our classify. We know that the longest side is in fact the hypotenuse. We know opposite. Down here, it's opposite our known angle, our 67, and of course our 29.6 is our adjacent angle. So we're going to relate, looks like adjacent and hypotenuse, and that's going to put the ka in SOHCAHTOA. That's going to mean our cosine. We're going to take the cosine of 67 degrees and find the relationship between the adjacent and the hypotenuse. Very nice. Well, there it is, 29.6 over g. Hey, just like we did in the last problem, remember we can swap the means, or, well, however you want to work it. Let's swap those two around. I now have 29.6 over the cosine of 67 degrees. Let's go to the calculator on this one. Use a table the last time. And, oops, come on, calculator. And we're going to have to get a calculator upgrade here. Woo, turn your phone sideways, and there you go. You've got 29.6. And we're going to divide by the cosine of 67 degrees. You've got to, again, practice with your calculator up front. Some of you have to use parentheses. We don't on this one. 67, I hit the cosine. That number looks good. That's 3907. That's the same as we get on the trig table. And then we just hit the equals, and we're done. Hey, rounding that one to the nearest tenth, what do you got there? I got 75.8. Finished. One more for good luck. All right, we're getting pretty good at this, so jumping right into it. Um, there's my opposite side, opposite my 57 degrees. This is the hypotenuse, and of course the adjacent side's over here. And let me see, I'm using the angle 57. Relative to that angle, I want the opposite. I know the adjacent. Hey, that looks like our good friend tangent in SOHCAHTOA. So I'm going to take tangent of 57 degrees. That is the opposite over the adjacent. So let's write that one up there. I'm going to substitute. I'll put in k over 123.7. Looks good. And you remember what we did in this case. My variable's in the numerator. No switching around. Please don't switch these around. No need to. I've already got k there. You know, this is algebra 1. We're going to multiply both sides of the equation by 123.7, and it's going to look like that. So you just think, that's what you're doing. Because remember, it divides out nicely right there. So you're good. And then you can say, all right, I guess then that k is simply 123.7 times the tangent of 57. Hey, and this time, let's go back to the trig table. Let's go old school here. Taking an excerpt out of our trig table. Again, it's in your textbook. It's in everybody's textbook. Going down to the third column, I want you to notice this. Heavens to Murgatroyds, this is the first time in our examples that you've seen a number bigger than 1. That's right. The tangent, unlike the sine and cosine, can be greater than 1. And you'll see this. You'll see this in angles greater than 45. And it makes sense because one leg can be longer than the other. I'm expecting k to be bigger than 123.7. So let's see. Let's take that and what do we do? What do we do now? Oh yeah, let's take that number. I'm going to take it out of the trig table, and then we'll pull out our handy dandy calculator. 123.7. Look at this. We can use that cheap 4-banger that we got for free, and we're going to multiply it times 1.5399, and there you go. 190 and a half, and we are done. Excellent.